All right, today we're diving into a tool that is seriously changing the game for how people build artificial intelligence. It's called Ludwig, and its whole promise is, well, it's simple, but it's also incredibly ambitious. Letting you build custom, state-of-the-art AI models just by describing what you want, instead of writing thousands of lines of crazy complex code.
Yeah, let's just think about that for a second. What if all that heavy lifting in machine learning, the data processing, figuring out the model architecture, all those training loops, was just handled for you? I know, it sounds almost too good to be true, right? But this is the exact problem Ludwig was built to solve. And to get why that's such a huge deal, we first have to understand the problem it's up against. Okay, so let's get into it. Building a machine learning model that's actually ready for the real world has always been this long, complicated journey. It's like navigating a maze of code, endless experiments, and heavy-duty engineering. And it's a totally fair question. We hear about AI being everywhere, but actually going from a cool idea to a working model, that takes a ton of specialized, low-level coding and deep expertise. The barrier to entry has always been insanely high. This slide really gives us a concrete before picture. This data comes straight from Uber, which is actually where Ludwig was born. I mean, just look at these numbers. A single project for intent classification took 7 months and 1,500 lines of code. Fraud prediction, 5 months, 900 lines. This isn't just about writing code. It's a massive investment of time and resources for every single model. So when you're faced with a maze like that, what do? Well, the team at Uber came up with a brilliant solution, a totally new way of thinking about building these models, all centered around what they call a declarative approach.
This right here is the core philosophy. Instead of writing out step-by-step instructions for the computer, the how, a declarative system lets you simply state your goal, the what. You just define your inputs, you define what you want as your outputs, and you let the framework figure out all the messy stuff in between. And this just lays it out perfectly. On the left, you've got the old way, the imperative approach, writing hundreds, or as we saw, thousands of lines of code. But on the right, you have Ludwig's declarative approach, one simple configuration file. You're basically shifting from being an ML mechanic with grease on your hands to an ML architect designing the blueprint. And here it is. This is what no ML code actually looks like in the wild. This whole file is just telling Ludwig, hey, I've got this input, it's called sentence, and it's a bunch of text, and I want you to predict an output called intent, which is a category. That's it. Seriously, that simple description is your model. No other code required. But what if you want to get a little fancier? Maybe you want to use a really powerful pre-trained model like BERT to make your model better. Well, you just add one line, encoder BERT. Ludwig takes care of all the crazy complexity of downloading it, integrating it, and training with it, all behind the scenes. They call this opt-in complexity. It starts simple, but it's got all the power you need right when you need it. And this is the payoff. Remember that 7 months, 1,500-line project we saw from Uber? With this declarative approach, that kind of task can be squeezed down from months of painful work to just days, or maybe even a few hours of tweaking a config file. It's a total game changer. So how in the world does Ludwig actually pull this off? It feels like magic, right? But it's not. It's based on a really, really clever and modular architecture. Let's pop the hood and see how it works. The secret sauce is something called the encoder-combiner-decoder architecture, or ECD for short. And honestly, the best way to think about this is like Lego blocks. Ludwig has all these different pre-built blocks for handling any kind of data you can think of. Text, images, numbers, categories. And you can just snap them together in almost any combination you want. So here's how your data flows through those Lego blocks. First, your raw data, text, images, whatever, gets pre-processed into something called tensors. Think of these as the universal language that AI models speak. Then, the specific encoders, those Lego blocks for each input, turn that data into smart numerical representations. Next, the combiner block cleverly merges all these different inputs into one unified piece of information. And finally, decoder blocks take that combined info and make predictions for each of your outputs. So this modular Lego block architecture is exactly what makes Ludwig so incredibly flexible. It's not just for one simple kind of task. It can handle a massive range of problems, from the basics all the way up to the most advanced AI models out there today.
And because it's so versatile, you can tackle this incredible range of jobs with the exact same framework. You can build a text classifier, you can predict stock market trends, or you can even build a system that looks at a picture and answers questions about it. The same declarative idea handles it all.
But let's be real. The most exciting application of this whole architecture today, well, it's got to be its ability to handle large language models, or LLMs.
Okay, get ready for this because this is just wild. The incredibly complex, super resource intensive process of fine tuning a massive LLM like Llama 2 is reduced to this simple config file. You just declare the base model you want to use, you point it to your instruction and response data, and you tell the trainer to fine tune. That's it. Ludwig handles everything else.
And here's the kicker. Just because it's simple doesn't mean you're sacrificing power. Ludwig makes all this cutting-edge stuff super accessible. Things like LoRa and QLoRa, which are just clever ways to fine-tune these giant models using way less memory. It also brings in tools like DeepSpeed to help you train on multiple GPUs, all managed through that same simple declarative file. Okay, so let's zoom out. Let's bring this all together. Why is a tool like Ludwig so important? Why is it such a game changer in the world of AI right now? Well, first of all, this isn't some tiny side project. We're talking over 9,100 stars on GitHub. That's a ton of trust and respect from the developer community. And it's alive and kicking. It's not just sitting on a shelf, it's being actively developed and improved by a huge community of over 130 contributors. And people are actually using it in the real world. With thousands of downloads every single month, it's clear this thing is being adopted to solve real problems. So when you put it all together, you get what we can call the Ludwig advantage. It's accessible, which means it's opening the door for people who aren't deep learning PhDs to build powerful AI. It's scalable, meaning the same simple config file can run on your laptop or on a massive cloud cluster with a bunch of GPUs. It's reproducible, which is absolutely critical for good science and reliable business. And finally, it's extensible, so experts can easily plug in their own custom code when they need to. Which really just leaves us with this one last thought. By radically simplifying how we build and train these incredibly sophisticated AI models, Ludwig doesn't just change how we work with AI, it changes who gets to build with it. It opens up a whole new world of possibilities. So the real question isn't just what Ludwig can do, but if building custom AI really becomes this easy, what will you create?